In this video, I'm going to explain how to count number of negative numbers present in a given array. So the first line is a comment here, you can see here. So you have to add in a project, you have to add right click the source group and add new item to the source group, and you have to select ASM file and you give file name as count neg or count negative dot asm. Dot asm is extension. So I already added dot asm and I typed the file, I typed the program here. So the line is second line. First line is a comment. Second one is area. The area name is count negative. No, so just given negative, or you can just give any label. You can give count negative or just negative. Anything you can give. It's just a label, and that area is actually both type. It is read only memory. Next is export space underscore underscore main. Two times underscore should come. So next is fourth line is underscore underscore mean it is a label. So in the startup file, the line number 131 is load or not with address of underscore underscore main. So in our program, we are using the same label so that it can fetch the address of this main or program main. So underscore underscore main. See, only labels you have to start without space. All other instructions you have to give some space. And here move R5 with 7. So why R5 is loaded with 7 here means in the array, okay, you have taken 7 datas. If you take 5 datas, you have to just type 5 here. If you write 10 datas, you have to write 10 here. So here, for example, we have taken 7 datas. So initially load R5 with 7, and this is a counter for negative number. R2 is equal to 5, 0. So R2 will hold the count of negative numbers. So one register you have to use as a counter. You can use R2 or R3 or any other register you can use. There is no rule that you have to use R5 for number of data. So any registers R1 to R12 you can use. Here we are using R2 as the counter which will hold the count of negative number. Load R4 with the address of array. Then loop is a label. So load R4 or load R1 content of R4. So R4 is actually having the address of R4. R4 actually R4 is having the address of array. So this is the array address. So it will fetch the data, first data, that is 1 2 3 4 5 6 7 8 into R1. After that, post increment will take place. R4 will be incremented by 4. Within a bracket, R4 is there now. It is actually having the array address. After fetching, it will be incremented by 4 because it should go to the next data. So one data is 32 bit, it is equivalent to 4 bytes. So post increment you have to give 4. So next, logically shift left side the R1 content by 1 time. This is the logical shift. If I shift left side the 32-bit data, it will move to carry. Okay. Here actually they use different registers R0, R2. Okay. Or you can also directly give. You can write like this, or you can. This instruction is also correct. What we using is also correct. So here what it will do, logically shift left side the R1 register content by 1 time. So if you move left side the MSB bit, 31st bit. So how to identify the number is negative or positive means you have to check MSB bit of 32 bit. If MSB is 1, the number is negative. If MSB is 0, the number is positive. So if you shift logically left side, the MSB bit will go to carry. After that, by checking carry whether it is set or not, you can decide the number is positive or negative. So logically shift left side R1 content by 1 time. So MSB bit will shift to left side and it will go to the carry position. After that, you check carry. Branch to found label if carry flag is set. CS means carry set. B means branch or jump. So in that found we have incrementing R2 is equal to increment by 1. So R2 is equal to R2 plus 1. R2 is equal to R2 plus 1. So increment by 1 time. Suppose if it is not set, so you have to skip this increment statement. You have to skip these two instructions. This instruction you have to skip. So unconditional jump, branch to or jump to loop 1, or B, loop 1 means branch or jump to loop 1. So in the loop 1, since there are 7 datas, so one first data we checked, so we have to decrement this counter, R5 counter, that is number of datas counter. So subtract R5 by 1. So R5 is equal to destination is also R5, R5 minus 1, and S means update the flag. Sub S means subtract R5 by 1 and update the flag. After that, compare whether R5 is equal to 0. 7 data are there, no? After 7 data checking, R5 becomes 0. So until R5 is not equal to 0, if not equal, go back to loop. Once again, load the new value of R4. R4 previously it was incremented by 4. Now R4 is pointing to the next data. It will fetch the next data, and again it will logically shift left side by 1 time. And if it is carry flag is set, that means if MSB is 1 for that data, we are finding one more negative number, so it increment R2 counter. So this will repeat how many times? 7 data are there, no? First time it is a 0 0 1, so left side it is 0, so it will not increment. This is first MSB bit is 1000, 8 means 1000, so here it will increment R2. Again this is 001, so it will not increment. 3 means 0011, again not no increment. E means 1110, so here MSB is 1. A means 1010, so MSB is 1, it will increment. 9 means 1001, so it will increment. So 4 negative numbers are there here. Okay. So now we can compile this program. So we are getting 0 errors and 0 warnings. This is if you are getting some warnings 1 and 2 errors, you can just give align statement. It will automatically align. If I comment this, you will get some warnings. So warnings are actually okay. We can execute. So that warning is added 2 bytes of padding at address 20, at line number 22. So here, if I just give align, automatically it will align the data and will not get the warning. So that is even warning is there. You don't write align also, it will work. So after that, start debug. Okay, it is going to start a file. Will fetch the address of underscore main, and it will go to our main program here. So move R5 with 7 because 7 data we are giving. R2 is a counter for negative number. Initially it is 0. Now you take R1, load R1, the content of R4. You can see the array. The array address is actually 10. Actually, this is actually present somewhere in the memory. Let me check in the second memory. Yeah, here you can see this is the 1 0. 4 zeros, 5 0, 1 0, 1. Somewhere it will be there. Okay, I have to get the address means Somewhere it will be there in the memory. So we don't know that address. Okay. So now let us don't worry about this. Let us go to this answer now. Okay, now um, yeah, here we are getting here. Load R4. The address of array is 124. So in 124, okay, in memory 2. Actually, I wrote 101. It is 124. Okay, see here. This is the data, and address this one to unsigned long 1 2 3 4 5 6 7 8. The second data is 8D data. Third data is 1111. Fourth data is 333. These are the data. So now I think you can check signed also. You can see here. Signed also you can see this is positive number, this is negative number, this is positive number, positive number, negative number, negative number, negative number. Here only you can check signed long. Okay. So unsigned only you give because you have to consider actual data. If you convert into signed it automatically, MSB will be considered as signed bit, remaining magnitude it will show. So now you can see first data is taken into R4. Okay, 1 2 3 4 5 6 7 8. Automatically R4 will be incremented by post increment by 4. So you can observe here R4 is 124. Okay, that content 1 2 3 4 will be transferred to R1. Then R4 is incremented by 4. This R4 will be 128 after the transfer, and R4 is loaded with R1 is loaded with first data 1 2 3 4 5 6. See 1 2 3 4 5 6 7 8. It is post incremented by 4. After that, logically shift left side. So you have to see the carry flag also. So this is the carry flag. Once I shift logically left side, that MSB is actually 1 means 0001. So after shifting also carry is 0 only. Only if it is carry flag is set CS, then only it will increment. It is found and it will increment R2, otherwise it will not increment. So it will go to branch loop 1. So we are skipping this line. Branch to loop 1. So we not executed this R2 increment by 1. So after the subtract R5 by 1, now it is 6. It is not equal to 0. Okay, not equal to 0. Branch not equal means go to jump loop. Label is loop here. It will jump to that loop label. So control is come to loop here. So again, next you have to shift load R1 with the new value of address of R4. That content will be copied here. R4 address is 128. In 128 we have 8D48, like that one. It will transfer to R1. Again, shift logically left side. Okay. So that time you can see carry is 1. Already it is executed. So it is not executed. You can now see the carry is 1. If carry is 1, okay, it is found. That means it should execute or add R to 1. So it is executing this marker, you can observe. So negative number count is incremented by 1. Again, okay, compare R5 is equal to 0 or not. If it is not equal, go back. Again, after post increment, it is incremented to 1282 12C. That is, it is pointing to the third data 1111. So load that 111 into R3, R1. Okay. Again, post increment is taken here. It is incremented by 4. So again, check for carry is generated or not. So 7 times it will repeat. Every time it gets carry is equal to 1, that is carry flag is set to 1, it will increment that counter. Once that R5 becomes 0. It is still 3. Now R5 is 1. When R5 is equal to 0, Z flag is set to 1. And if it is R5 is equal to 0, compare R5 is equal to 0. If it is equal, if it is not equal to 1, that is Z flag is not equal to 1, it will go back to loop. Now it is actually equal to 1. So it will not branch to the loop. Instead, it will execute next. So we have to store that answer in negative count. So we have declared one more variable in the data area. The label area name is result. It is a data memory where you can do read operation as well as write. It's a read write location. So we declared one negative count. Next count define constant data and initialize to 0. So we have to write that count value to this variable. So get the address of this. How to get the address? Okay, load R6. We have to use new register. Load R6 is equal to means address of that. And after that in R2 we have that count now. So store R2 into this address specified by R6. So it will come to here. So this address we have to get what is the address of this negative count. So the negative count address is this one 10000. That is there in the memory 1 window. So I already typed yeah, if it is not there, you have to type 0x 1 followed by 7 zeros. Press enter. Initially you can see all the memory contents are 0. Now R2 value is how much? 4 negative numbers. No, that 4 will come to here. See, it will take 1 second or 2 seconds to come here. So this is indicating number of negative numbers in a given array. The array is this. All the 7 data are ready here. See, this is actually unsigned long. If you turn it to signed, here only you can check it out. Negative number. See, first number is positive, second number is negative, third is positive, fourth is positive, fifth is negative, sixth is negative, seventh is negative. So 1, 2, 3, 4. 4 negative numbers are there. So how to check negative number, positive or negative? By checking MS. Okay. So this is how to check number of negative numbers in a array.